Today, we're going to pull back the curtain on SQL. It's the language that's quietly running the show behind almost everything you do online. Think about your social media feed, your Amazon cart. Yep, that's SQL, keeping all that data in line. So let's dive right in. So how does all that magic happen? Well, it all comes down to a database, and the special language we use to talk to that database, to ask it questions, to tell it what to do, that language is SQL. It's the key that unlocks all that information. Here's our game plan. We're going to start with the basics, what a database even is. Then we'll get our hands dirty, building one, adding some info, and then asking it some questions. And to finish up, we'll look at the really cool part, connecting all the dots. Okay, so first things first. What exactly is a database? Honestly, the easiest way to think about it is like a super organized digital filing cabinet. It's a place where you can store all your information in a really structured way, so it's a breeze to find exactly what you're looking for later on. And SQL? Well, if the database is our filing cabinet, SQL, or structured query language, is the language we use to talk to it. It's how we say, hey, create a new folder for me, or go find that file from last week. It's our command center. Now, you should know there are kind of two main flavors of databases. The ones we're talking about, relational databases, they use SQL and they're like that perfectly organized filing cabinet. Everything has its place. Then you have no SQL databases, which are more like a junk drawer. Super flexible, you can toss anything in there, but it's not as structured. Today, we're sticking to the neat and tidy world of SQL. All right, so we've got our filing cabinet. What's next? Well, an empty cabinet isn't much use, right? We need to create the folders inside it. In SQL, we don't call them folders. We call them tables. And these tables are what's going to hold all of our data. To actually build these tables, we use a specific part of SQL called DDL, which stands for Data Definition Language. The best way to think of DDL is like the blueprints. It doesn't care about the papers you're going to put inside. Its only job is to build the cabinet and the folders themselves. The three main DDL commands are super simple. You've got create, which builds a new table. You've got alter, which lets you change a table you've already made. And you have drop, which, well, it completely deletes the table. It's just like managing folders. And look at how clear this is. This is a real command. It's a direct order to the database that says, create a new table, called it employees. And I want it to have two columns, one for an ID, which will be a number, and one for a name. And just like that, here's what we get. That one little line of code gives us this perfect empty table called employees, all set up and ready for us to start adding some information. Okay, our folders, our tables are all set up. So the next logical step is to start filing the papers, right? We need to actually put some data into the tables we just built. And for that job, we use DML, or Data Manipulation Language. So if DDL built the structure, DML is all about manipulating the data inside that structure. It's the language we use to handle the files themselves. And the core commands here are, again, really intuitive. To add a new piece of data, we use insert. To change something that's already there, we use update. And to get rid of a record, you guessed it, we use delete. So let's look at an example. This command is telling the database, hey, I want to insert a new record into my employees table. For the ID and name columns, I want you to use the values 1 and John. And bam, just like that, our employee John is now officially in the system. So let's recap. We've built the structure and we've put some data inside. Now we get to the most powerful part of all, asking our database questions to find exactly what we need. This is where DQL, the data query language, comes in. And honestly, this whole part of SQL basically boils down to one single, incredibly powerful command that you are going to use all the time. And that command is select. If you remember only one thing today, make it this one. Anytime you want to get information out of your database, your sentence, your question is almost certainly going to start with the word select. What's really cool is how much it reads like a normal sentence. Let's break this down. Select the name, from the employees table where the ID is 1. The database would look at that and immediately tell you the name you're looking for is John. It's that simple. Okay, time for our final concept, and this one is a real game changer. You might be wondering why we don't just dump everything into one giant table. Well, it's about staying organized. But what happens when the answer you need is split between two different tables? That's where joins come in to save the day. So, imagine we have one table just for our customers. Pretty simple, right? We can see that customer ID 101 has the name Alice. Then, in a completely separate table, we're keeping track of orders. And here we see that order number 901 was placed by customer ID 101. See that? That customer ID column is in both tables. That is our link. That's our connection. To connect these two, we use what's called an inner join. Now, this command looks a little long, but it's just telling the database a story. It's saying, select the order ID and the customer name, and you're going to have to look in both the orders table and the customers table. I want you to join them together right on the spot where the customer ID is the same in both tables. And would you look at that? SQL takes information from both tables and pieces it together for us. It gives us the complete picture. We now know, without a doubt, that order 901 belongs to Alice. This ability to link related data is what makes these databases so incredibly powerful and efficient. And that's really the heart of it. From building tables to asking them complex questions, that is the essence of SQL. It's not just about writing code. It's about learning how to have a structured, intelligent conversation with data. So the only question left is, now that you know the language, what questions will you ask?